Okay, so welcome back. Now in this video, it's going to be a short video, but I want to show how we can start to use the limit laws to help us with other limits. So for example, if we look at this sequence here, 1 over n squared. Well, we know that the sequence of 1 over n converges, right? So this sequence approaches 0. As n approaches infinity, right? Well, then it makes sense that 1 over n squared is, because what is 1 over n squared? It's just 1 over n times 1 over n, right? And so using the limit laws, it makes sense that, hey, then this, right, behaves the same way as this. So if this approaches 0, then I can take those two, right? So this, and I can take the individual limits of these, right? And I know the limit of this goes to 0, and the limit of this goes to 0, right? We've already shown that. So then the product of these would also go to 0. Which then shows that this is also goes to 0. So 1 over n goes to 0 by using the limit laws. Furthermore, we know that, well, any power of that is then converges to 0. So then we also know that 1 over n to the k, for any positive k value, positive integer k I should say, will be 0. So we know, based on the limit laws, that the limit as n approaches infinity of 1 over n, or excuse me, well, what we showed before was the limit as this approaches, as n approaches infinity of 1 over n is equal to 0. We showed that before. And then by using the limit laws, we know that the limit as n approaches infinity of 1 over n squared equals 0, because this is just the same as the limit as n approaches infinity of 1 over n times 1 over n, right? Which is equal to the limit as n approaches infinity of 1 over n times the limit as n approaches infinity of 1 over n, which equals 0 times 0, which equals 0, right? And so again, we can keep doing this over and over again using the same limit law, and we get finally that the limit as n approaches infinity of 1 over n to the k is going to equal 0 for all positive integers. Okay. Okay. Let's do some examples now.